So in this video, we're going to talk about solving a matrix using the inverse function. And just like we solve matrix, just like we would solve an equation, let's take an equation and try to solve, if we want to solve 3x minus 4 is equal to, let's do 17. If I want to solve this, what would be my process? Well, my process would be to add 4 to both sides. And then I get 3x is equal to 21, and divide everything by 3. And so when I do that, I get x is equal to 7. So just like solving an equation, a matrix works pretty much the same way, except there are two big differences that we need to account for. And the first one, probably the biggest one, is that there is no division of matrices. So this part where we're dividing by 3, we can't do that in a matrix. There's no such thing as that. And the other thing is the commutative property doesn't exist, so it matters how we multiply our matrices. So when we solve a matrix, then we're going to take the equation that looks like this. We're going to start off with our equation that says a times x is equal to b, where a is what we call our coefficient matrix. It's called the coefficient matrix. And x is what we call our variable matrix. And b is what we call our constant matrix. Right? And if I want to solve ax, and the goal here is to solve for this variable x, the variable matrix. I want to solve for that. So if I want to solve that, I can see that I need to divide by a. Well, there is no division of matrices. And because there is no division of matrices, the way we divide with a matrix is we use the inverse. And so if we try to divide this by a or multiply by the inverse, we're going to get this equation right here. X is equal to a inverse b. So the first step in doing all of this is to actually set up what we call our matrix equations. And it's basically looking at these 3 different matrices. So here's how we set those up. If I want to set up a matrix equation for this particular system here, what I do is I first write out my coefficient matrix. For this particular problem, the coefficient matrix, which we'll call A, has the numbers 1, -1, +1 on the first row. Second row has 0 for the x1 variable, 2, -1 for the x3 variable. Third row, 2 for x1, 3 for x2, and 0 for x3. Next thing I'm going to do is I'm going to write my B matrix. My variable matrix. So my variable matrix here is the 3 variables that are sitting in the actual problem, which are x1, x2, and x3. And that has to equal the constant matrix, which are the numbers that are sitting out here. That's equal to 1, 1, 1. And now this is the matrix A, this is the matrix B, and this is the matrix X. And if we multiply this out on this side, it'll give us this system over here where it equals all these variables. We can look at that real quick and see that we have from here. Remember, we do a row times a column. So I do 1 times x1, and I'll get x1. -1 times x2, and negative x2. 1 times x3, a positive x3. And that has to equal whatever's sitting up here, that first element, 1. If I do it again for the next row, 0 times x1 is a 0 here. 2 times x2 is going to be a positive 2x2. -1 times x3 is a negative x3. And that has to equal another 1. And on that final row, I'll do 2 times x2, 2 times x1, which is 2x1. 3 times x2, which is a positive 3x2. And then 0 times x3, which is just 0. And that has to equal 1 as well. So we can go back and forth between the matrices like this. And now the goal next thing is we want to solve these matrices. So we're going to start off by solving a 2x2 matrix. And in order to solve a 2x2 matrix, remember, we need to use the new equation that we have, which is A R x is equal to A inverse B. So in order to find this, we need to start out by finding the a variable. And so or actually, let's start by writing our matrices out. So we'll start off by writing the A matrix, which is 1, 2, 3, -5. The variable matrix, which is, in this case, we have x and y. We're going to call y x2. We're going to call x x1. Which means the variables x1 and x2, write the general system. And it's equal to the constant matrix, which in this case is 4 and 1. So the first step here is to actually generate the A inverse matrix. And to find A inverse, we're going to use the determinant for a 2 by 2. And remember, we find the determinant of A, the determinant of my A matrix in this case, it's equal to, we multiply A times D. So we're going to multiply 1 times -5, and we're going to subtract off B times C. So we're going to subtract off 2 times 3. When we do that, 1 times -5 is a -5. 2 times 3 is 6, but that's a -6, so it'll be -5 minus 6. That is a -11. So the determinant here is -11. So now that we have the determinant, the next step to find the inverse, so to find A inverse, what we do is we're going to, remember, we need to flip the diagonal right here. Flip these values right here. So we're going to flip 1 and -5. It'll change spots, so this becomes -5. This becomes 1. And then we negate this diagonal. So we're going to make this a -2, and it's a -3. So remember, that's when we start the process. And we have to multiply that by the determinant. We have to multiply that by the determinant. So A inverse, move this over. I'm going to multiply that by 1 over -11. So when I do that, I get -5 over 11, -2 over 11, -3 over 11, and -1 over 11. Sorry, all these negatives should be positive because we're multiplying by negatives there. So there. That's what we should get. So this is the new matrix that we're going to multiply. This is the A inverse matrix. This is A inverse. So we want to solve the equation. Well, we have x equals, in this case, A inverse times B. So I'm going to take A inverse as 5 11ths, 2 11ths, 3 11ths, -1 over 11. I'm going to multiply that by the constant matrix, which was 4 times 1. And so when I multiply this, let's see what happens. We're going to multiply a row by a column. So we get, in this first element, row, 5 11ths times 4 11ths is 20 11ths. And then 2 11ths times 1 is just 2 11ths. So this is plus 2 11ths. Let me get away row by a column. 3 11ths times 4 11ths, that's going to be 12 11ths. And then -1 11th times 1 is -1 11th. If we clean this up then, and this, all of this has to equal the variable matrix, which is equal to x1 and x2 here. So when I clean that up, 20 11ths plus 2 11ths, this cleans up to be 22 11ths on the top. And on the bottom, 12 minus 1 is 11 11ths. That has to equal x1 and x2. And this just cleans up. 22 over 11 is just 2. 11 over 11 is 1. So now I see x1 and x2 are equal to 2 and 1 respectively.